This video is on the objective determine the p-value for a hypothesis test for the mean. And this is with population standard deviation known, right? So sigma is known, and that tells us that the test statistic we find for a sample will be a z-score. We'll be working with the standard normal distribution. And this is number 1, right? So it's the first video on a question related to this objective from your Newton Alta homework that I'm looking at. And let's take a look. Alright, so first off, if you want to see more on the topic, more on the objective, please click on more instruction. Look at their videos, their notes, their examples, and hopefully those help you out. Alright, so we're asked here simply, what is the p-value of a two-tailed one-mean hypothesis test with a test statistic, a z-score for your sample mean? The z-score of your sample mean is negative 1.01. And it says do not round your answer, compute your answer using a value from the table below. Alright, so let me refresh your memory as to how to find the p-value for the different kinds of tests you'll come across. Right, there's going to be left-tailed tests, right-tailed tests, and two-tailed tests. And I've written these out in previous videos, so I've got the writing here. Let's get rid of the calculator. Alright, so this was forming hypotheses. Now remember, the way what kind of a test you're running has to do with the way the alternative hypothesis looks. If the parameter is not equal or different from a value, you're running a two-tailed test. If you have a parameter is greater than a value, you're running a right-tailed test. And if you have the parameter is less than a value, you're running a left-tailed test. Alright, now in a left-tailed test, now that's the critical value approach, we're doing the p-value approach now, finding p-values for a test statistic. If in a left-tailed test, you find your test statistic, what's the z-score or t-score, but here it's a z-score because the population standard deviation is known. And then the p-value is simply the area to the left under the curve, the area to the left of that test statistic. And then to decide whether or not you reject the null hypothesis, you compare the p-value to the significance level, to alpha. Right, and if the p-value is less than or equal to alpha, you would reject the null hypothesis. If it's greater than alpha, you don't reject the null hypothesis. But for a left-tailed test, again, the p-value is simply the area to the left of your test statistic. There's right-tailed test, critical value approach. And then for a right-tailed test, using this p-value approach, it's simply you have your test statistic identified, and then the p-value is the area to the right of the test statistic under the curve. And same comparison, when you're deciding whether or not to reject the null hypothesis, if the p-value is, again, less than or equal to alpha, you reject. If the p-value is greater than alpha, you don't reject. Alright, then I guess the trickiest one is for a two-tailed test. Now this is the critical value approach. We're doing the p-value approach. Alright, for a two-tailed test, it all depends on where the test statistic lies. Alright, if the test statistic is above the center, if the test statistic is above the mean, you're going to find the area to the right of the test statistic and then double it for the p-value. Right, the p-value will be double that area to the right. And if the test statistic ends up being left of center or less than the mean, then you're going to find the area to the left of the test statistic and double it. All right, so again, the p-value will be double this area to the left. And then you make the same comparisons as left-tailed test, right-tailed test. You make the same exact comparison to alpha, to the significance level. If the p-value is less than or equal to alpha, you reject the null. If the p-value is greater than alpha, you don't reject the null hypothesis. Okay. So we've seen now, how we're going to find our p-value. All right. Now, let's go back. Now, they told, no, I'm not going to go back. Let's write the information we had here. They told us we have a two-tailed test in this problem. They told us it was a two-tailed test. And they told us our test statistic, right? I like to call it z sub test. I know they have z sub 0. But just to remind myself that it is the test statistic, right? The z-score of our sample mean. They said it was negative 1.01. Right? So if I set up the standard normal curve, right, the z distribution, right, standard normal, that had a mean of 0 and a standard deviation of 1. Symmetrical bell-shaped curve here. Under the peak, right, remember the mean of the population should have a, it has a z-score of 0 under the peak of the standard normal curve. And then our test statistic, right, the z-score for our sample mean comes in at negative 1.01. So over here. Right. Now this is clearly below the mean. Right. So since it's below the mean, I'm in a two-tailed test. I mentioned this a second ago. I'm going to find the area to the left. Right, we're going to find the area to the left of this test statistic under the curve. And then the p-value for our test statistic will be twice that area. Right, we're going to double that area. All right, now they said use a table, but you could also use a calculator. Pull up the calculator here. Let's find, now remember, to find the area under a normal curve, I go to second, hit that variables button, you go distributions, and that normal CDF. And they want, what's the area of this left region here, this left tail? There is no lowest value, so for the lower value, I'm going to enter some big negative number, and there's something already there. It's negative 99999, so I'll leave that. The upper value of this region is my test statistic, the negative 1.01. And then the mean is 0, the standard deviation is 1, right, for a standard normal for these z distributions, right? And that's how you'd have to enter it on the old ones, right? You have to put the comma, put your left value, comma, right value, comma, mean, comma, standard deviation. All right, and this area is coming up as, 0.1562, blah, blah, blah. And then I'm going to double this, right? So this area to the left is approximately 0.156, so almost 16%. But then for the p-value, again, because it's a two-tailed test, I'm going to multiply this answer here by 2. So the p-value is approximately 0.312, right? 31%. And then I would compare this p-value to alpha to decide whether or not I'm going to reject the null hypothesis. All right, but this is all we were asked for here, right? The p-value. Now, looking at the table, we could also have found this. Now, remember a z-score table? The numbers in a z-score table give you areas to the left. So when I look up the z-score of negative 1.01, so negative 1.01, right? So this third row, second column here, you see it, I'm seeing this number 0.156. That was the area to the left of the z-score negative 1.01. And that's exactly what I got on my paper. Right? Area to the left, 0.156, rounded to 3 decimal places. But then for the p-value though, right, two-tailed, because it's two-tailed, I'm taking this area to the left and doubling it. So the p-value is 2 times 0.156, or that 0.312 that I wrote down on my paper earlier. And that's all we're asked for here, just simply finding the p-value. And again, see, they say two-tailed. There's negative 1.01, positive 1.101. You know, double the area. Right, the area to the left of negative 1.01 is the same as the area to the right of positive 1.01. But like I said earlier, just take the area to the left and double it. Right. And again, read through your answer explanations, of course, especially if you're wrong. Right, read through the answer explanations and see if you can figure out where you went wrong. And that way, when you come across the same kind of problem again, hopefully you do better. Alright, so hopefully this video helps you with this kind of a question. I'll put out another one for maybe some extra help, and thank you very much for watching.